This meeting is being recorded.
Problem 8.18 shows us some examples of reactions that undergo hydroboration, oxidation. So we should be familiar now with the reagents that are needed to perform this type of reaction, this type of transformation. So we have our borane, our tetrahydrofuran in step 1, and then we have hydrogen peroxide in basic conditions listed for step 2. So they ask us to consider the radioselectivity for these types of reactions and then draw the product. So we know that we're going to add in an anti-Markovnikov fashion, right? We're going to add H and OH across our pi bond. So let's do H and OH in an anti-Markovnikov addition. So with our first reaction here, our first molecule, let's pick out where's the more highly substituted position that would normally, under Markovnikov conditions, get the OH. That will now get the hydrogen. So I don't need to draw anything there, but I will draw, on this end of the double bond, right, we're going to draw our OH over here, coming off. So this is, again, anti-Markovnikov conditions, so the least highly substituted position will get the OH. All right, so let's take a look here. Our next reactant is a cyclic structure. So here is the more highly substituted position. So that will get the hydrogen. And then on the other end, we're going to add the OH to this molecule. So again, anti-Markovnikov conditions, we end up with the least highly substituted position. So this was a primary installation of an OH group instead of a secondary. Our last molecule, so we have more highly over here, we'll get the H. Less highly substituted position, we'll get the OH. So that, again, will be on a primary position instead of a secondary. So these are our 3 predicted products with hydroboration oxidation reactions, which our radioselectivity would be anti-Markovnikov addition of H and OH.